As you've probably seen over the past year, we've started cooking and heating our water for hot drinks using battery power rather than gas, a lot more often, whether it's using our lithium leisure battery and inverter or a portable power station. So with various different methods of doing this, like kettles, microwaves, induction hobs and coffee machines, stick with us while we look at if any of those methods are more efficient than others, so can save us battery power. Don't forget to check out our other videos on everything campervan and motorhome related, from solar to water, heating to gadgets, tyres to trips. If you like this video, please do hit the thumbs up, it really does help me to know what you like, and you can ask any questions or give feedback in the comments. If you want to make sure you don't miss any of our future videos, please hit the subscribe button, and clicking the bell will give you a notification when a new video goes live. Finally, if you do decide to hit the thumbs down, it would be great if you could also leave a comment so I know what you didn't like. Using electrical power to heat food and drinks is becoming more and more popular in campervans, caravans and motorhomes. And when connected to mains hookup, how you do it probably comes down to what is quickest and most convenient. But when off-grid and using battery power, every watt used could be the difference between having enough power and running out. All the different ways of heating food or drink work on similar basic principles, so let's take a look at that to start with. The appliances take electrical energy and convert it into another form. Ohmic or resistive for a kettle, electromagnetic induction for induction hobs, and electromagnetic radiation for microwaves. These energy forms are then used to increase the temperature of the food or drink. But at each of these changes there is a loss or inefficiency. Add to that we'll be using power through an inverter, where there is also loss, which can vary depending on the load and the type of use. We're going to be using the AllPowers R1500 power station for this test, as this has the most capable inverter that we have, with 1.8 kilowatt continuous and 3 kilowatt surge pure sine wave capability. It also allows us to monitor the power draw on the battery live. We'll have a full review of this coming soon, but you can also find a product link in the video description if you want to have a look at it now, as it's currently discounted to just £799.99. We're going to start by using a mains plug-in kettle. For each method we'll use 500 millilitres of water and measure the temperature at the start and at the end, our target being around 60 degrees C. We'll use these measurements along with the measure of the electrical power used both at the output socket and at the load on the power station battery. Using all this information, we'll calculate how much power on average each method uses to raise the water by 1 degree Celsius, and therefore how efficient the method is. We're clearly not in laboratory conditions, but we'll try and keep things as accurate and consistent as we can by having the same volume of water, similar temperature changes, and helping to reduce loss of heat from the water by covering containers in each test. So let's get started with our 800 watt travel kettle. We can see that the starting temperature for the water is 16 degrees C. And we're going to switch it on and measure the power used until it reaches approximately 60 degrees C. Watching all of the tests in real time would get pretty boring, so we've sped up all of the tests. Reaching approximately 60 degrees, we've switched off and we've used 34 watts. We're giving the water a stir just to make sure that we're getting an accurate measure of the temperature of the water. And that's 58 degrees C. We're now going to repeat the test with our coffee machine, and this is why we picked a target temperature of around 60 degrees, as this is the one item we can't change the temperature on and it heats to 60 degrees. As this uses a thermoblock heater, the power usage starts warming that block up before the water starts flowing, and it can then switch on and off during the water flowing, so you'll see that the power goes up and down. Put the power meter display on instantaneous to show this, but we'll look back now and see the total usage is 33 watt hours to reach 62 degrees. By comparing the instantaneous AC power of 1392 watts and the 1401 watts of DC output, we can see that for this method and load, the inverter is very efficient. Now let's try our 800 watt microwave. Previously the water starts at 16 degrees C. To create the 800 watt heating power, the microwave was pulling 1100 watts from the battery, and we had to restart it a couple of times when the water hadn't got hot enough. Finally, after using 56 watt hours, when we stirred the water to even out the temperature, it was at 59 degrees. Finally, we're going to try an induction compatible kettle on an induction hob. The kettle is a bit colder, so the water temperature has dropped to around 14 degrees C. And it looks like it's reached around 60 degrees when it's consumed 38 watt hours. But because we know the water at the bottom of the kettle near the heating area will be higher than at the top, we pour out the water to mix it all up and check the temperature again, showing that the true temperature of the water is actually 71 degrees. Here are our detailed results, but let's jump straight to a summary. The induction kettle appeared to use the least power measured at the AC output, very closely followed by the coffee machine. But when looking at the power draw at the battery, we saw that the inverter was more efficient when powering the coffee machine, which meant the actual power taken out of the battery was less. This is likely to be due to the type of load and the fact that the coffee machine used a higher power draw for shorter bursts than the induction hob, which was around half the power but on for longer. The plug-in kettle wasn't far behind, especially as the inverter was pretty efficient with that as well, but the microwave used not far off twice the power that the coffee machine did. So, is it as simple as that? When it comes to making coffee, the coffee machine is the most efficient, and for hot water, the induction hob kettle is slightly better choice than a plug-in kettle. And microwaves are inefficient. Well, yes, and maybe not. When it comes to microwaves, the way they heat, their efficiency is affected by what they are heating. In very simple terms, microwaves heat by bombarding the item with microwaves. This causes molecules in the item to vibrate and rub against each other, which generates heat. As more dense solids have a greater density of molecules to vibrate and rub against each other, more heat is created. Let's see how well the microwave does at heating 500 millilitres of beans rather than 500 millilitres of water. The beans start at 17 degrees. After heating the beans for just over 2 minutes, we give them a stir and the temperature is around 55 degrees C. And the power usage is 38 watt hours. Compare that and let's also warm up the beans on an induction hob. So these are fresh beans at 17 degrees C. To allow the beans to get to a consistent temperature, we're taking them out of the pan, giving them a stir, and we'll measure them again. And we can see they're at 48 degrees. We've added the beans results to our details table here. And here is our summary. As you can see, both the microwave and the induction hob use 1 watt-hour to raise the temperature of the beans by 1 degree C. Again, as the microwave is using a higher wattage for a shorter period of time, and the inverter in the power station does this more efficiently, it uses slightly less power at the battery. So whilst the microwave is not a good choice for heating water, for heating more dense items, it does as well, if not slightly better, than the induction hob. Thanks for watching our video, and as always, if you have any questions or feedback, please pop them in the comments below. If you find the video useful, please like, share and consider subscribing.